we ended, which is vectors. So now vectors are represented in most cases by arrows. Sometimes we also use letters, small letters that have an arrow on top. Then we also have roots, that is having two letters, let's say AB. Let's say if we write A, B with the arrow on top. So this can represent a vector. Sometimes we can represent a vector in this format where we write that then with a small letter and the arrow on top, like that. In mathematics, we are not going to be surprised. We're going to see a small letter which is underlined to represent a vector, like that. That is in mathematics. So not to waste time, what we have to know is this. So the arrow or the length of the arrow represents the magnitude of the vector. Then the arrow head represents the direction. So in this case, when we look at this example, 10 newtons. So this 10 newtons where we see starting from this tail up to the arrow head, this is representing the magnitude of a vector. And the arrow, which is the head here, it is representing the direction. So two vectors can be added to form a resultant vector. So the addition of two vectors forms a resultant vector. So now the other thing that we're supposed to know is that there are two methods of adding vectors, or you can also use some other methods, but specifically we're going to deal with two. So now there are simple addition methods, so let's describe these two types. So this is used when both vectors are parallel, same or opposite direction. That is simple addition method. So when the vectors or two vectors are parallel, which means same or opposite direction, which means we can use simple method of addition. Let's go to the next part. Okay, so now when it comes to direction of vectors, when both vectors are parallel, same or opposite direction. So in this case, we are having same direction. So in the same direction, if let's say we're having 4 newtons and 4 newtons in the same direction, what is going to be our resultant vector? So in this case, we are looking at forces that are going in the same direction and are parallel. Then next thing, so we're going to say resultant force is equal to 8 newtons to the right where they are pointing. So now, where is this 8 newton coming from? So you just add 4 newtons plus 4 newtons, which is giving us 8 newtons. The next thing, if let's say we're having vectors or forces that are in the opposite direction, but they are parallel. So now, the resultant vector, how is it going to be? So now, this one which is going to the left, we can say that this one is negative. So this one we can consider it to be negative. So we're going to say the resultant force, which is R, is equal to, that is negative 4 newtons, negative 4 newtons plus positive 4. So this positive 4, it is like that. So if two equal vectors are parallel and in the opposite direction, then the resultant vector is going to be equal to 0. So in this case, we're going to have 0 newtons because these two forces will cancel each other. So let's proceed and look at the next example. Okay, so let's see the next example. Let me just cut out this, clear up some space for this other work. Hope there is no problem. We're understanding everything that we have to understand. Okay, so now let's proceed. So with this example, we're having the negative vector. Which is 4 newtons, and we're having the other vector which is parallel to negative 4 newtons, which is 9 newtons. So let's find out our resultant force. So in this case, the resultant force is going to be equal to 5 newtons to the right, where there is 9 newtons. So now, what we mean by this? So we're going to say resultant is equal to, so we are going to start with, we can start with anything because addition is commutative. So we're going to say negative 4 newtons plus 9 newtons. So in this case, we're going to see that the resultant vector is going to be positive 5 newtons, like that. So now if we had another example, so let's say if this side where there is 4, there was a vector which is, let's say, vector 6 newtons, then this other side, if we had the vector which is vector 3 newtons, then if we try to add this, we're going to see that the resultant vector is going to be solved in this pattern. So we're going to have negative 6 newtons plus positive 3 newtons. Then this one, the answer we're going to have is negative 3 newtons. So the negative is just showing us that the working is going to the left, which is the negative side. Then let's proceed and look at the parallelogram method. So that is simple addition. Now let's see the parallelogram method. So for the parallelogram method, this is used when both vectors are not in the same straight line, which means they are not parallel. The resultant vector is represented in both magnitude and direction by the diagonal of the diagram, with two given vectors as adjacent sides. Then that is joining the two tails of the vectors first, then complete the parallelogram, and lastly draw the diagonal. Hope there is no problem with that. So let's see in the next page what we are going to have. So now, this is what we mean when we come to the parallelogram. So in the next video, we'll start with this example, then just solve it and see how it's working.